Hello, sixth graders. Today's going to be a quick and easy lesson. We're talking about parallelograms and kind of some features of them. Parallelograms made up of 4 sides, and the pairs of sides continue forever. They're made up of parallel lines. So measuring angles will be really easy working with parallelograms. Let's take a look here. We have a parallelogram right here, and they tell us we have to find out what the x is. Well, we're going to go ahead and label all these things because they give us one clue. They give us the other part of z is 130. Well, if this is 130, this is a straight line, so what is angle z? Angle z has to be 50 because 130 plus 50 equals 180. If this is 50, over here we've got a 50 because they're exact same angle dealing with parallelograms. Okay. Well, if this is 50, then that means that this outside angle here has to be 50. So that means that this has to be 130. And if this is 130, that means, oops, wrong button. That means that this right here is also, angle W is also 130. Now, we can check our work just to make sure that we're doing it correctly, because if we have a shape with 4 angles in it, it equals 360 degrees. Well, 50 plus 50 is 100, equals 100. And 130 plus another 130 would be 260. If I add up all 3 of these numbers, I get a total of 360 degrees. So angle x equals 50 degrees. Okay, angle y is 130. And the reason why we know is because we're dealing with adjacent angles on a horizontal line, which equals 180. So when we're adding up to 180, it equals, so we have to just subtract what we know. We know 130, so we're going to subtract 180 minus 130 is 50. Let's take a look at this next one here. So we're taking a look here at this shape. It says the only way to find the length of sides CO, right here, and OA is to measure them through. Explain why he is incorrect. So Alexi said that the only way you can find the lengths of these sides of CO is if you measure. Well, this is a parallelogram. That's also a rectangle. This has 90-degree angles in it. So if this is 90, this has to be 90, 90, and 90. So what this means here is this, kids. Opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram. Let's see if I spell that correctly. P-A-R-A-L-L-E-L-O-gram. Opposite sides of a parallelogram are congruent, which means they are the same. So if this is 30 centimeters, this is 30 centimeters. If this is 10, this is 10. That's how we could explain that he's incorrect. Last one here. So how are we going to measure MAR? Well, it's pretty easy, and let's go ahead and measure all these angles in here and see if we're capable of doing that, okay? So let's see here. So MAR right here, so this is 70. MAR right here has to be 110 because 110 plus 70 equals 180, okay? So if this is 110, that means right here we have 110 as well, okay? And if this angle right here is 110, if this angle is 110, that means down here below, these two angles that are connecting, I'm going to kind of show you with another object right here. So I'm going to extend this line out to help make sense of this, okay? If this right here is 70 degrees, that means this is 70 degrees inside here. But this is broken apart into 2 angles, because if this is 110, this is 110 out here, okay? Just keep this in mind here, okay? But this right here isn't really 70 because it's broken apart into 2 angles. So I'm just going to move this 70 out to the side, but these 2 angles equal 70. But I have a 40 here, and if I were to kind of flip these triangles, that means I'd have a 40 right there. So I'm going to go ahead and put a 40 right there. And what I know is a 40 plus a 30 equals 70. I love these problems. And if that's a 30, that means I have a 30 up here. Now I'm going to go back and check my work to see if I did this all right. 30 plus 110 is 140, plus 40 is 180. This is a triangle, and all the angles inside a triangle equal 180. Same thing with the math here, 40, 30, and 110. So checking our work, I made a lot more work for us than I needed to, but I kind of like explaining this to you just so you kind of understand what's happening. What is the measure of MAR? Well, it's 110, okay? But MKR is also 110, and these labels and these angles in here aren't labeled, okay? Let's keep cruising on here. Draw a parallelogram in which all the sides have the same length and all the angles have the same measure. What is another name for this parallelogram? Well, that's easy. That would be called a square. Does that follow the rules of that? These are parallel to sides. They all have the same length and they all have the same sides, so it'd be called a square. Okay. Let's see how this next one goes. Draw a parallelogram in which all the sides have the same length and no angle measures 90 degrees. What is another name of this parallelogram? Okay, all the sides have the same length. So essentially, it is like a square. Let's see if I can turn a square on here. It's a square, but it's a square that they're not letting me move it. Okay, that doesn't work. It's a square that can't have 90-degree sides. So if we think about it, if I have a side here, this is how I'm going to do this. I'm going to copy this. So I have all the same lengths so you kids can see exactly what I'm doing. Okay? I'm going to paste this like this. Tilt it. Like that. Look what I'm making, kids. I am making, I know a lot of you are probably already seeing it, we're making a rhombus. All the sides are the same length. This obviously doesn't work because this is a square with all 90-degree angles. But draw a parallelogram with all the same length and no angle measuring 90 degrees. What's another name for it? This is called a rhombus. A lot of times kids want to call that, wow, I spelled that wrong, a diamond, okay? Hopefully this helps, kids. A little bit of practice with parallelograms, and just once again, I know we've been doing a lot with this. Today's lesson should be really easy, but just a nice little refresher because our unit test is coming up and you'll be ready to rock and roll with it. Hopefully this helps, and I look forward to working with you in math today.